Welcome back to Math 107 College Algebra. In this video, we're going to take a look at horizontal and oblique asymptotes. So the textbook uses a different method of finding a horizontal asymptote than I prefer. We can find the horizontal asymptote in the exact same way that we find an oblique asymptote. That is, if I give you a function p of x divided by q of x, although in this case I do not really like having q of x, so I'm not going to use it. We'll call that denominator function s of x. Well, we know under long division that we can rewrite this as some sort of function q of x plus r of x over s of x, where the degree of r of x is less than the degree of s of x. So now what we can do is looking at an example, so we'll say we go with one that has an oblique asymptote. So 2x cubed over x squared plus 1. So I do long division on this. So x squared plus 1 divided into 2x cubed. And then I'm going to put the other terms in here, plus 0x squared plus 0x plus 0. So I get 2x out of that. So 2x squared, 2x cubed plus 2x. Subtract those off. So I get a minus 2x. So all I have left is that. So I get plus, or I'll actually write it minus 2x over x squared plus 1. So now as I put bigger and bigger values in for x, that fraction that I have on the end is going to get really small. That numerator is going to get bigger at a slower rate than the denominator is. So eventually that's going to get closer and closer to 0, so the function's going to start looking closer and closer to that 2x. So that would be what we call, in this case, an oblique asymptote. That's saying that when I graph the function, so that oblique asymptote is something like that, graph of our function is going to get closer and closer to that line. And with an oblique asymptote, it is possible that it will cross it at times. Usually it's going to be more down in this region. We're talking about getting closer and closer without crossing as we get to very big numbers, but not necessarily when we're small. So that's how we find an oblique asymptote. And it would be the same thing to find a horizontal asymptote. That's just going to have a constant term when we do the division and not a term with x. In class on Monday, we will actually take a look at some problems where we have asymptotes that aren't linear. And we can use the same idea there that we have here.